Yeah.
We should get you a ring. Kill me.
All right. So today we're going to talk about the formation of sedimentary rocks. So write in your little notes. First, let's write down the objective, which is this thing. Oh, that's actually the objective from last time. We're going to write down sequence the formation of sedimentary rocks. Sequence the formation of sedimentary rocks. Oops. What? Sedimentary rock. So we're talking about sedimentary rocks. Do you remember what I forced you to say is inside your little jar? Sediment, right? Where did mine go?
You left it on my note.
Oh, this one, thank you. Sediment. So now Tylee can see it. Is Tylee in it?
That would be hilarious if she wasn't.
It says he's not live.
What? No, it is live. It's been a minute and 15 seconds, which is like 10% of the time I allotted for this. Anyway, so we have a little jar of sediment. She's not even in there, but she will watch it eventually. Natalie, come on, we're talking about posterity.
You can't use my name.
Yes, I can. Just can't play your first and last name. Anyway, we're gonna have to start this whole thing over. Natalie, come on. So there's some sediment in there. It is a little awkward, but we're gonna get through it. There's some sediment in there, and there's also some water. I wish Tylee would show up. Tylee, stop it. Okay. So, how did the sediment form in the first place? How did the sediment form in the first place? How did the sediment that you picked up from the parking lot or the road or whatever get? Yeah, there you go. Okay, erosion. So we know one of the words, erosion. There's something else that goes along with this. Please stop laughing. What's the other thing that goes along with this? You know what other we're going to talk about. You might not know what they mean, but we're going to talk about that too. What's the other one? Erosion and weathering. So you're aware from the past or from your life that these are things that we talk about when we talk about sedimentary rocks. Do you remember what they mean specifically? Like this is the primary question. This will be on all your tests forever. What is the difference between weathering and erosion? Oh, you can't see that at all. How are we going to do it so that you can't see it? I'm sorry, Tylee.
This is what she sent me. She said, "You want to be able to do it," and she's logged in with her.
Video is frustrated.
Yeah, it happens when you use Google emails.
All the time?
Yeah, like every other video.
Does she have a different account she can log in? She doesn't have to be your CPS or anything. Anyway.
Is this all recording?
Yeah, this is fine. We're doing fine. We can cut it later, I'm sure. Or maybe not. It doesn't matter. Anyway, like I said, this is for Tylee. And Levi. We've forgotten about Levi. So what is the difference between weathering and erosion, Natalie? Do you know? Does anyone know?
Sure. I don't know. Here, let me look at my.
No, it's okay. We don't need to do that because I'm going to tell you. So, two things had to happen for the sediment that's in this little jar to get there, right? First of all,
Those aren't really
well, fine. First of all, what was this sediment before it was sediment? Yeah, it was rocks. It was larger rocks, right? So something had to happen there. And then other than that, what else was true about the rocks that made this sediment before the sediment was sediment? Was it always here? Has it been here since the dawn of time? No. So two things had to happen. It had to be what? When it used to be rocks and now sediment, it had to be okay. There you go. It had to be broken down, right? And then it also had to be eroded, which is in another word.
Like
Transported. Okay, so good. So weathering. Maybe if I write it larger. Try again. Weathering is the breakdown of rock into sediment, while erosion is the, what could we say? There we go. Transport of sediment. Hopefully that's not as backwards in the actual video as it looks like it is on mine. Patrick, is it backwards when you watch YouTube live videos in real life? Oh, great. So that means it probably is on this one.
I can check for it if you want.
How can this be even more obvious?
You have to have like a camera on the back of your phone.
Oh, you mean like it's from the front camera?
Yeah, so I don't know if it's like.
I feel like you should be able to.
Like I should be able to flip it though. Anyway, okay, we got 4 minutes left to talk about this. So what are some various things that could cause this, do you think? Weathering. What could cause weathering? Sure, yeah. It's just the breakdown, right? So anything that breaks a rock. So we could say like crashing into other rocks, right? The method by which that takes place doesn't really matter. Well, I mean, it does make a difference, but it all becomes weathered sediment, right? She should be able to watch it.
She logged in as another account and it says storage.
Mr. Can you tell me what it is like fresh looking?
Yeah, my YouTube name is just David Kyman. But that's like my first name and my last name. Anyway, usually this takes place. I didn't say mine. It's my own life. I can do what I want. So I just can't make you do
Say
it.
her name.
Yeah, yes, I can. Not your first and last name. Don't say it, Natalie. Anyway, so usually this takes place when this other takes place too. Now, what are some things that can cause this one? And we'll spend a lot of time on these in the future, but for now, just some like examples of what can cause erosion. Okay, water. Water in general. Well, let's think of some subsets of water, but what else? Okay, so let's just think of the subsets right now. Rivers and streams, what else? Leave a blank spell under that one because we're going to put the fancy name for each of these underneath it. What else can cause erosion? Okay. What else?
Like sub or like just whatever.
What other kinds of water can cause erosion? What other kinds of water are there? Okay, yeah, tides. We'll put oceans and tides. Good. What else?
Like
Waves of the ocean, maybe? I'm thinking of other bodies of water. You're right, yeah, the waves of the ocean, certainly. Lakes, yeah. Okay, so that'll cover most of them.
That's exactly what I just said.
I'm sorry, I thought you said waves.
No.
Lakes. Yes, good, Skylar. Yes, lakes. So there's a fancy name for each of these. I'm going to do it in a different color. The rivers and streams, that one's called fluvial. F-L-U-V-I-A-L. Fluvial. Fluvial. F-L-U-V-I-A-L.
She said, can you just send it to me?
Yeah, it'll be on the Google Classroom.
Yeah, I was going to say it's more.
There's not really a fancy name for rain, but you probably can think of the fancy name for ocean, the ocean one. What's the fancy name, the Latin name that we use when we're talking about the oceans? Marine. Yeah, marine. Kind of ran out of room here. And then the lakes we call lacustrine. So these are just some fancy names we use for the water erosion. What other kinds of erosion are there? Thinking of two specifically. What's that? Say it again.
You were talking about erosion.
Yeah, two. There's other besides water erosion. What other kinds of what other kinds of erosion are there? Wind. Okay, good. And wind has its own fancy name too, which is we call it eolian. It's spelled A-E-O-L-I-A-N. Eolian. This is related to the Greek word for air, which is Aero, A-E-R-O. And the last kind of erosion, just because we don't have a whole lot of time, I'm just going to tell you, is what we call mass movement, where it's just under the influence of gravity. Well, let's include glacial too, actually, Patrick. You're right. Glacial. Let's include glacial. Thank you. So, now listen. This is all about, both of these two things are how sediment is formed, right? But the title of the lesson is Sedimentary Rocks. So how do these two things, you probably remember from the past, how do these two things, or the sediment that's caused by those two things, how does this become a rock? Well, it's not a rock right now. Okay, it could be under the influence of heat and pressure. What else? You know? You said it.
Again?
Yeah, I think so.
It's squished together.
Squished together, right? And there's a fancier word than squished together that we use in science, and it is compaction. Compaction. What else could cause these little grains that are making up the sediment to stick together?
Water or something.
Okay, water and minerals could grow between them, and we call that cementation, like the word cement. You know cement. Like what the sidewalk's made out of. Compaction and cementation, right? And both or just one of these can happen to make the sediment into a sedimentary rock. And you had a vocabulary word that was what I just said. The process by which sediment becomes a sedimentary rock. What is the word for that? Lithification, thank you. Both of these are kinds of lithification. Kind of ran out of room. Compaction is where if we have our sediments here and they just get pressed down, what would press them down over time? Yeah, gravity, other layers of rock, right? The more of this piles up, the bottom layer will get squished together and they'll be compacted into a rock. What could cause this? This is relating to what we talked about in minerals 2 chapters ago. What could cause them to be cemented together? You already said it after. Say it again. Yeah, if there's water in between them, which there is.
Which can degrade the minerals inside.
And by degrade you mean dissolve, right? So there's already minerals in the water, but there's also minerals in the sediments, and either of those can dissolve in water. And then when the water evaporates, even if we just let this evaporate, some of the minerals would kind of grow in between the existing sediments, hooking them together, right? Good on that? Yes, okay, good. So in both of those ways, the sediment that's in that little jar can become rock through lithification. And the last thing we're going to talk about real quick here is, mine's not as good. Who did I say was better? Snap, please. You can see, we're going to pass this around. I'm going to show it to the little, yours is really bubbling. I'm going to show it to the camera so that Tylee and Levi can see it, but yeah, you can see there's different, Natalie, you know, because you've already seen it. Hannah, you know, because you've already seen it. This is also yours. What is different about this one and mine? Oh, mine fell over.
Way to go.
Okay, just forget about that one. What's this one got that's special in it, though? It has got something maybe decomposing in it. What else?
It has a layer of sediment.
Yes, exactly. That's what I'm looking for. Thank you. It has layers of sediment, right? So, I don't know, maybe you couldn't even see on the screen, but there was like this layer of silt down here. And then what's nice about theirs is that it has this layer of just like larger, you might even be tempted to call them rocks or pebbles. And then on top, yeah, grains. And then on top of that was some sand. And then on top of that was some silt. And then on top of that was some more clay. And we'll talk about the different geological symbols for these things, for sediments in the future. But for now, this little bit here, not the bottom one, but this little bit here is called fining upwards, and it's a kind of bedding. And we're gonna write the word bedding over here somewhere. Let me guess this. Fining upwards. What do you think that means? As we look up in the little, it gets finer and finer, right? And this is a type of bedding, which is what we call how the sediments lay down, right? Oh, look, lay down in bed. That's so nice. In general, the reason that bedding occurs is that whatever erosional medium, this is an extremely important concept, whatever erosional medium is carrying the sediments, the faster it's moving, the more energy it has. Faster moving erosional media, faster moving erosional media. Well, hold up, what's erosional media? Singular erosional medium, what might that be? Yeah, those specifically, but like, could you define what I mean by erosional media, which singular is erosional medium? These are the examples of it, but in general, these are all things that do erosion, right? The erosional media is the thing doing the erosion. So the faster moving the erosional media is, the more energy it has, and the larger sediment it can carry. I already knocked mine over, so I can do this with it. So when I first picked it up and I was shaking it all around, fast moving or slow moving erosional media when I'm just shaking it? Fast. So what size of sediment could it carry relative in here? Larger. So if I move it really fast, it can carry the largest sediment that are in here, right? In fact, I will shake it hard enough that I'm sure even the largest sediments that are in here are being carried. And then as I set it down and let it rest over the weekend like we did, what does it do? Like, what does the speed of the erosional medium do? Slows down. And so then, since the faster it is, the larger the sediment can carry, as it slows down, what's the first thing that falls out? The big sediments, right? So what we see nicely in Natalie and Hannah's is that the big sediments fell out first, then the littler ones, then the small. It gets smaller and smaller. It binds upward, right? And that's a type of bedding. That's called graded bedding. So write that down. Finding upwards is graded bedding. Last thing before we say bye to our friends in cyberspace.
It's so awkward.
Yeah. Oh there are two other things we need to talk. Well, I mean, there's one thing, but there's two parts of this. So we're going to talk about sorting and rounding. Sorting is whether all the sediments are the same size. If they are all the same size, it's called well sorted. If they're all different sizes, it's called poorly sorted. If all the sediments are the same size, we call that well sorted. And this has to do with what kind of erosional medium it's in. We'll talk about this later, but depending on the kind of erosional medium, the sediments either become well sorted or poorly sorted. This is due to erosional medium. For instance, glacial deposits are very often poorly sorted. There's all different sizes of sediments mixed in. Whereas Aeolian sediments are almost always well sorted. They're all sorted by what size they are. You've heard the word sorting before, right?
Yes.
If I were to sort you guys by hair color, I mean, I'd put the people with the same hair color together, right? In the same way, in well-sorted sediments, all the same size sediments are together, and all the different size ones, well, there aren't any different size ones. They're all sorted together. And then rounding, you can probably guess what rounding is. What the sediments are. How round, thank you, the sediments are. And this one, depending on the erosional medium, this may or may not be true, but usually, the longer they spend in the erosional medium, the rounder they get. This marker is dying. It's already impossible to see on the YouTube. Longer spent equals rounder. Let's say longer time spent equals rounder sediment. Usually. I wouldn't call this a catastrophic failure, but if it wasn't an F, it was a D. We'll try this again better in the future, but this was a nice trial run. Yeah, exactly. It's first time. Bye, Levi. Bye, Tylee.
I could not do it.